Safety cabinets Class 2 working safely. A Class 2 safety cabinet can offer adequate protection during aerosol-forming activities with pathogenic microorganisms. The airstream aimed inwards in the work opening and the suction in the front and back of the worktop are primarily responsible for the protection. The airstream aimed downwards in the working area of the safety cabinet has passed through a HEPA filter. This makes it possible to work in a sterile environment. The HEPA filter for the extracted air protects both the worker and the environment. Microorganisms released during the work are caught in the HEPA filters. Adequate protection of the worker and sterile working conditions are only possible when the airflow in the working area of the cabinet is not disturbed too much. The air in the proximity of the cabinet should also flow steadily. A number of examples of disturbed airflow in and out of the cabinet will demonstrate that a Class 2 safety cabinet only provides the protection we expect from it when it's used in the proper manner. Disruptions outside the safety cabinet. Air inlet grills can blow air into the laboratory at great speed. Should the cabinet be positioned in an unfavorable area in relation to this air supply, the protection the cabinet should provide could be decreased. A draft caused by open doors or windows can also have a negative influence on the protective factor of the cabinet. Employees walking past the safety cabinet cause air movement, which is capable of transporting particles from the cabinet into the laboratory. This can be made visible by generating smoke in the cabinet. In this test, we have to keep in mind that during normal walking, air speeds are generated which have a much higher rate than the airspeed at the window aperture of the cabinet. Disruptions in the cabinet. The laminary downflow should be disrupted as little as possible. The walls of the working area in the cabinet should therefore be as free as possible from protruding parts. In this working area, there are no protrusions on the front panel. Released particles are therefore transported almost directly to the extraction slit at the front of the worktop. Disruption of the downflow is caused by an ultraviolet lamp mounted high against the panel of the working area. The volume of air expelled by the extraction slits at the front and back of the worktop has been critically regulated. Partial covering of these extraction slits can completely nullify the protection the cabinet is supposed to provide. Therefore, an absorbent napkin should never cover the front extraction slit, because this could be the result. But if the particles do not get outside the work aperture, protection of the worker is severely reduced. Particles released in the work area of the cabinet should be transported to the filters as quickly as possible. Placing objects in the back extraction slit cause the air to be extracted from the front of the worktop rather than the back. This increases the risk of particles being released into the laboratory. Objects placed on the worktop will disrupt the airflow over the worktop. A rack for automatic pipettes with a closed back will block the airflow to the extractor slits at the back of the worktop. The resulting eddies can cause particles to contaminate the experiment. A rack with an open back will disrupt the airflow much less. In this case, a closed container of materials will block the removal of particles through the extractor slits at the back of the worktop. Placing these materials in a basket will deflect the airflow much less. Some of the equipment used in the safety cabinet can cause an unexpected disruption of the airflow. The engine of this water bath pump is cooled by a ventilator. The ventilator causes such a strong airflow over the worktop that particles are blown from the cabinet into the laboratory. Using Bunsen burners in a Class 2 safety cabinet requires special attention. Even mini burners are capable of affecting the downflow to such an extent that the airflow cannot transport the particles directly to the filters. Even the pilot light of a mini burner can create eddies above the worktop. A burner fitted with a spark ignition operated by foot switch does not require a pilot light. The effect on the downflow in the work area of the cabinet can be dramatic, even during short periods of use of the burner. Apart from the effect on the downflow, the use of Bunsen burners can reduce the protection of the worker and disrupt the registration of the airspeed in the cabinet. Alternatives are available for a number of standard procedures which make the use of Bunsen burners superfluous. Bottlenecks can be cleaned with disinfectants. Grafting onto plates requires the Bunsen burner to be in use for a considerable time in order to heat the eyes correctly. Working with sterile disposable eyes not only makes the use of a burner superfluous, but also saves time. After placing a culture on a culture medium with a glass Drygalski, it has to be sterilized with heat. Disposable plastic Drygalskis are available for this type of work. Platinum needles are used to draw fluids. Sterile plastic straws, clamped in a special holder, are an alternative to platinum needles. Scientist and safety cabinet. Arm movements can seriously disrupt the downflow in the work area of the cabinet. Rapid movements cause more eddies than slower movements. It should also be taken into account that particles released close to the hands can be propelled into the sleeves by the descending airflow. The rapid airstream which flows across the worktop towards the extractor slits at the front of the worktop can blow particles into the sleeves. Gloves should be drawn over the sleeves, or sleeve covers should be used. Another ill-recognized source of contamination is sleeve contact with particles precipitated around the extractor slits at the front of the worktop. This precipitation is made visible here by nebulating particles which light up under ultraviolet rays. The nebulated particles inside the cabinet precipitate around the extractor slits. Nebulation in the air drawn in by the work aperture cause this contamination. The underarms often rest in the front of the worktop during the experiment. Particles precipitated near the extractor slits can be swept up by the sleeves. These particles can be released over the experiment or contaminate the sleeves. It is virtually impossible to prevent contamination of sleeves in safety cabinets which have not been fitted with armrests. Therefore, safety cabinets which are fitted with armrests are recommended. The correct sitting height also reduces the risk of contaminating the sleeves. Using a Class II safety cabinet in the proper way ensures adequate protection of both the worker and the experiment. The following procedure is an example of this. This can deviate per laboratory, type of experiment, or type of safety cabinet. Collect all materials required for the experiment in advance. Bringing materials into the cabinet during the experiment increases the risk of contamination. When the safety cabinet is not in use, the work aperture should be closed. Use of the safety cabinet starts with the removal of the plug from the sealing plate. The ventilation and lighting can now be activated. Remove the sealing plate from the work aperture. Mount the airflow edging to the worktop and adjust the window to the lowest position. Disinfect the worktop and airflow edgings with a suitable disinfectant 10 minutes after the safety cabinet has been activated. The airflow edgings around the work aperture, and especially the materials around the front extractor slits, should be disinfected well, as most particles precipitate here. Place all the required materials in the safety cabinet. Make sure that the downflow in the work area of the cabinet is disrupted as little as possible. Move as gently as possible. On completion of the experiment, all materials should be disinfected before removing them from the cabinet. Also on completion of the experiment, disinfect the worktop again, and especially the front air extractor grill. Leave the cabinet switched on for at least 5 minutes on completion of the work. Floating particles will be removed through the air filters during that time. Replace the sealing plate in the work aperture, close the window, and switch the cabinet off. Replace the plug in the sealing plate. Complete the logbook of the safety cabinet. The logbook contains date, user, type of work, microorganisms used, chemical compound used, and any radioactive nuclei used. The safety cabinet is now available for the next user.